When faced with an equation that has a variable with a rational exponent, meaning an exponent with a fraction in it, the easiest way to clear that exponent, to get the x so that it no longer has that exponent so we can solve for x, is to raise both sides of the equation to the reciprocal of that exponent. So in the first example here, before doing that, we're going to isolate the variable by dividing both sides by 4. So if we do that to get started, we have x to the 3/2 equals 32 divided by 4 is 8. And so now I'm going to raise both sides of our equation to the reciprocal exponent. And so that will leave me with just x. And the reason that is because when we raise an exponent to an exponent, our exponent rules say that we multiply those exponents. Well, when I multiply two reciprocals, 3/2 times 2/3, I get 1. So that means this side is going to end up equaling x to the first, or just x. Now on the other side, we've got 8 being raised to the 2/3 power, so we're going to have to simplify that. And the way we're going to simplify that is by rewriting it in radical form and then doing what we've done previously. So we've got x equals, so remember the denominator is the root, so we have the cube root of 8 squared, or 8 times 8. And so now I need to work on getting any perfect cubes, any triples out from underneath the root symbol. So either we can recognize 8 as being a perfect cube and just do it that way, or if we go with the factor tree approach on each of these 4s and 2s, remember we need 3 of something, not 2 of something, since it's a cube root. But if we factor tree this couple of 4s into 2s, there's 1, 2, 3 2s. It's going to come out as a 2. There's another set of 2s that's going to come out as a 2 and multiply the other one. So our final result on this one is x equals 4. So the approach we take is to isolate the x, and then we raise both sides of the equation to the reciprocal exponent, taking advantage of the fact that when you multiply reciprocals, which is what you do when you raise an exponent to an exponent, you're going to get 1. So then we just get x, and then we can solve using our simplifying techniques. In our second example, we don't just have the variable that's being raised to this exponent, but instead we have this entire set of parentheses. But that doesn't change anything for us. We're still going to get rid of that exponent by raising both sides to the reciprocal. So I'm going to leave it as is, x plus 6 to the 2/3, and then I'm going to raise that to the 3/2. And then on the other side, I just have 4 to the 3/2. So I'm raising both sides to the reciprocal of the exponent that I see. So when I multiply 2/3 times 3/2, just like we saw in the previous example, we're just going to get x plus 6, just x plus 6 to the first. And on the other side, we've got 4 to the 3/2. So I'm going to right away rewrite that in radical form so I can simplify it. So our denominator is 2, so it's going to be a square root of 4 to the 3rd power, or 4 times 4 times 4. So now, hopefully, we're recognizing all of those as perfect squares, so I can go ahead and just take the square root of each one of those. If I wanted to factor tree it and then pull numbers out in pairs, I could do that. So I get x plus 6 equals 2 times 2 times 2, which is 8. So I get x plus 6 equals 8. So then my last step is to subtract 6 from both sides, and I get x equals 2. So in the next example, we have a very similar circumstance where we have a set of parentheses being raised to a fractional exponent. So I'm going to take that side, x plus 12 to the 1/2, and then I'm going to raise it to the reciprocal of 1/2, so I'm going to end up raising it to the 2/1, or just squaring both sides. So on this other side, I get x squared. So now, when I multiply 1/2 times 2, I get 1. So I get x plus 12 to the first, or just x plus 12, equals, now on this side I still have this x squared, so a little bit different this time. Instead of just having a number on the right hand side, we had a variable. And so now we have an equation where we've got x squared as the highest exponent, which means we're going to have to solve using one of our quadratic techniques So in this case, I'm going to seek to factor it. So I'm going to pile up everything on one side of the equation, set it equal to 0, and then solve by factoring. So I'm going to subtract x from both sides and subtract 12 from both sides. So I'm moving everything over to where the x squared is positive. And so now I've got x squared minus x minus 12 equals 0. So now I'm going to do my factor tree work here. I get x and x. I'm multiplying to make a negative, so I need one positive and one negative. And so now I'm looking for two numbers that multiply to make 12, but add to make negative 1. And so I'm going to have negative 4 and positive 3. Negative 4 times 3 is negative 12. Negative 4x plus 3x will give me that negative x. So then I take each of these factors and set them equal to 0. And now I can go ahead and solve by subtracting 3 from both sides. So I get x equals negative 3 as one of my answers. And then if I add 4 to both sides, I get x equals 4 as a second answer. Now, we should be checking our answer certainly to make sure that we don't end up with a negative underneath the square root symbol, or a square root needs to equal a negative. And really, that's what this 1/2 exponent is it means it's the square root of x plus 12 equals x. So I'm going to take negative 3 and I'm going to plug it in for x. So negative 3 plus 12 is 9. 9, if I take the square root of that, I get 3, not negative 3. So I'm going to have to throw that answer out because it doesn't work. It means I have to have a square root equal a negative. But if I test 4, I've got 4 plus 12. I'm going to take the square root of that, and that's got to equal 4. Well, 4 plus 12 is 16. The square root of 16 is indeed 4. So that one works okay. So this time I ended up with an extraneous answer. So in these problems, whenever we get two answers, we should always be checking to see that both of those answers work, because it's very likely that we're going to have an answer that is extraneous. In our last example, we have a similar circumstance where we've got the set of parentheses is being raised to this 1/2 power. So the way I'm going to clear it is by raising both sides of the equation to the reciprocal, so to the 2/1. So I've got x plus 4 to the 1/2. So I'm going to raise that to the second. Now on the other side, we have to remember that exponents don't distribute. When we raise the side to the second power, we have to put it in a set of parentheses. So it's going to be the whole side that's being raised to that second power. So on the left, we're in pretty good shape. We're just going to end up with x plus 4, because the 2 times 1/2 equals 1. So that's just x plus 4 to the first, which is x plus 4. On this side, though, I'm going to have to use my FOIL technique to multiply. I can't just square the individual pieces. I have to put parentheses around the whole thing and FOIL to square it. So I still have the x plus 4 here on the left. On this side, I've got x times x, which gives me x squared. Then I've got two matching pieces for the outer and inner. A negative 2x, another negative 2x. So that gives me negative 4x. And then negative 2 times negative 2 is going to give me plus 4. So now again, I have an x squared in my equation. So I'm going to need to set it equal to 0 and try to solve by factoring or some other quadratic technique. So I'm going to move everything to the x squared side. So I'm going to subtract x in both sides. I'm going to subtract 4 from both sides. So I end up with 0 equals x squared. Then I've got negative 4x minus x, which gives me negative 5x. And then my 4's cancel each other out. So in this circumstance, I'm going to factor by undistributing. I've got an x that's in common in both of these pieces. So I'm going to undistribute an x. And then I'm going to be left with x minus 5. So now I take each of these factors, x, and set it equal to 0, and x minus 5, and set it equal to 0. And so then we close things out here by adding 5 to both sides. And so we get our two answers of 0 and then 5. And again, we should check our answers to make sure that they don't result in either taking the square root of a negative or a square root equals a negative. So if we go back to the original If I plug in 0 for x, if we start there, I get 0 plus 4, which is just 0, raised to the 1/2 power, which really means to take the square root of it, and then that's got to equal 0 minus 2. So hopefully, similar to the last problem, we can see that we're running into a problem over here where we're getting the square root of 4 is supposed to equal -2, but that should equal +2. So I'm going to throw that answer out. Now let's test the other answer, 5. If I plug in 5 for x, 5 plus 4 is underneath the square root symbol, and then that's going to equal 5 minus 2. So 5 plus 4 is 9, the square root of 9 is 3, and on the other side we're getting 5 minus 2, which is 3. So this one does work, so our only answer in this case is going to be x equals 5. So don't forget on these problems, if you end up with 2 answers, then you definitely need to check your work, check your solutions, because it's very likely that one of those answers will be extraneous and thrown out.